Mexico Bureau of Geology, which is down in Socorro. My career has been in studying volcanoes, mostly in New Mexico, but really all throughout the world. And what I wanted to do in this pretty short presentation is to provide a little bit of context for Capulin and kind of volcanism in this region. I'm originally from Kentucky, and I knew at a fairly early age how cool it would be to study volcanoes. But when I thought about volcanoes, I thought about places like Hawaii or Yellowstone. I never thought in a million years a Kentucky boy would end up in New Mexico studying volcanoes, but here I am. So I want to share with you a little bit about what I've done and kind of how I tried to study the geology in this area. Okay, so first thing I want you to do is I want you to imagine you're an astronaut. You're in the International Space Station, you're flying above the Earth, and you look down on New Mexico. This is what you'd see. I'm just sort of curious, when you all look at this satellite image of New Mexico, what are some of the things that pop out to you?
White sands.
White sands, yeah. Right down here, it's a little blue. The colors are a little tweaked in this, but that's one. Yeah, great. What are some other things that kind of come to your eye as you look here?
Mountain range.
There's mountain ranges, all these areas of green, those are our vegetated mountain ranges. You can see lots of desert. You can see the Rio Grande coming right through there, that little strip of green. Anybody see these little black marks here? So those are some lava flows, and those are sort of the youngest ones we know of in the state. This one here is about 3,000 years. The really long one's about 5,000 years. But everything you see there is a result of the billion-year-plus geologic history that's recorded here in New Mexico. If you were to make a real simple map of the volcanoes in New Mexico, this is what you'd see. So in purple, these are volcanoes that are between about 40 and 20 million years ago. There's a cluster of about 30 supervolcanoes down in this area that are pretty spectacular. If you've ever been down to like the Gila cliff dwellings, you're in a massive old supervolcano, all dormant. And what I've been doing for the last 10 years or so has been trying to understand the history of the volcanic fields shown in red there. These are the youngest volcanoes in the state, and they're important to study because we do think of New Mexico as still being volcanically active. And so sort of my goal for, like I said, about the last 10 years has been to try to put together the story of the most recent volcanism in New Mexico so that we might know what it does in the future. And so that's how I started working up here at Capulin National Monument. Hard to believe it was 10 years or so ago, but I came here to study the young volcanism. And I want to share that with you towards the end of my presentation, but to provide a little context, we need to kind of go back and talk a little bit about Earth. So Earth has these different layers. The layer we're on, we call it the crust. It's like this thin little outer bit. There's a part of the Earth's crust called the mantle, shown in red there. That's ultimately where all the magma that eventually forms volcanoes comes from. And then we have this core, which is shown on right. And sort of the classic analogy is an egg. It's got a nice shell as the crust. The whites would be the mantle, and then the core would be the yolk. So that's how I always envision it. Now the crust of the planet is not completely just one solid plate. There's about 12 or so major plates, and their boundaries are shown here. And if you were to kind of map out the eruptions and earthquakes over the last 100 years, they would almost perfectly line up with all these little lines as the plates move past each other. It causes melting, but you'll notice New Mexico, which is right about here, doesn't line up on one of these plates, and that's because there's a kind of a special thing that's happening here in New Mexico. If you were to take a kind of a slice of the earth, trying to understand these plates. There's a lot of words on here. I won't worry about them too much, but this is kind of what you'd see. In some places, the plates are moving towards each other. As one slides down, it causes melting. In some places, the plates are moving away from each other, and that causes melting. But here in New Mexico, we're not on a plate, but the plate's actually starting to break up into two, and it's an incredibly well-known feature in New Mexico called the Rio Grande Rift. A rift is just where the Earth's crust is pulling apart, and geologists from all over the planet literally come to New Mexico. They fly into Albuquerque, which is right in the middle of the rift, to study these features, to study the earthquakes associated with it, or folks like me like to study the volcanoes associated with the Rio Grande Rift. To move in a little closer, so on the left here's a simplified map of the volcanic field we're in, called the Raton-Clayton volcanic field. Here's Raton, here's Clayton, and all these colors are part of the volcanic. It was a very original name, right? Two towns were right in the middle, so we call it the Raton-Clayton volcanic field. Each one of these little dots or squares or triangles represents a volcano, so there's well over 100 volcanoes here. The oldest ones that we know about are about 9 billion years old, and the youngest one we know about is a little less than 40,000 years ago. So very long history of New Mexico volcanism here. On this little map, this is what I showed earlier. Here's the Raton-Clayton volcanic field. Here's this feature called the Rio Grande Rift, where the Earth's crust is being pulled apart. And you'll notice the Raton-Clayton field's not exactly on it, and that's because there's this big crustal weakness here where all these volcanic fields are lined up, where just like you could imagine a fracture in a water pipe, that liquid magma likes to find these crustal flaws and move up through. And so that's sort of why the Raton-Clayton field is out here. So Nico had a nice introduction to the type of volcano that Capulin is. It's called a cinder cone. This is a very simplified illustration of Capulin. If you had been here just before the eruption, you would have seen these fractures in the grounds with lava shooting up into the air, and as the lava cools, it kind of breaks apart and starts to build up this volcanic cone of ash and cinders. So you see these nice layers where the lava's coming out, being ejected upwards. It kind of hollows out the top of the volcano and makes a crater. And then commonly you get lava flows that spill out the side. This is a nice map, kind of zooming in on Capulin. So here's the volcanic cone. The visitor center that we're in is right over here. And all these different colors are different lava flows that leaked out of this volcano. Nobody saw this volcano erupt, but from when we've been able to observe these eruptions in the past, they're commonly fairly short-lived. They last sometimes as short as hours, days, more commonly months, and in some extreme cases a few years. But unlike, say, Mount St. Helens, where the eruption always happens in the same place and you build up this big volcano, here in the Raton-Clayton field, the volcanoes typically erupt once, again for a few months usually, and then the activity migrates somewhere else. There's some amazing features at Capulin, which is why it's a national monument. So one is when you're up on top, you can see all the different lava flows. This is looking out towards another volcano, but I'll show you. This is the outline of the lava flow right there, and that's just one of 4 lava flows that would have spread out. So if, again, nobody was living here, but if you were here when there was an eruption, that would be one of the major hazards, is kind of this lava flow coming towards your house or your road. All throughout the the flanks of the volcano, there are these fragments of cooled lava, which we call cinders. These are really important as you drive around in the Raton Clayton volcanic field. Many of the cinder cones have been mined for this material. It's good for building construction and landscaping. We also throw it on the roads in New Mexico in the winter because it heats up the road and provides traction. On the way up to the top of the volcano, you can see this nice layering from when the plume was depositing material down there. It's not me. Do you know how to get rid of that?
No, but
Okay, we'll keep going.
We'll just keep going through.
We'll just keep going. One thing to keep in mind is even though when you're standing on the flanks of Capulin, it seems like a big volcano, these are some of the smallest volcanoes that we know of on the planet. It's also why they're some of the most common, but here's a little comparison compared to some more well-known volcanoes. So here's Capulin down here versus Mount Rainier, which is a different type of volcano, and then here's Mount Rainier compared to a shield volcano like the Hawaiian Islands. And so Capulin's a very, very tiny volcano, but these are also the most common types of volcanoes on our planet. So, what have I done to help try to understand the volcanic history? So, my job as a geologist who studies volcanoes, or a volcanologist, is to first go out and collect volcanic rocks. So I go out and I make maps of volcanic fields where I can understand the location, where the flows are, and then I sample those volcanic rocks and take them back to a lab in Socorro where I can measure the ages of those volcanic rocks, so I can put together the history of the volcanic field to try to understand things like how frequently they erupt. Are they very active, or do they spend most of their time just sort of quiet and not doing anything? And here's some of the results that I found. So this is a map. Let me get you oriented here, kind of zoomed in on different places. So here's Raton. Clayton would be like over here. Here's Capulin, and this little star represents Capulin Volcano. Each one of these little stars represents another volcano. And by going out and mapping and dating these volcanic rocks, one of the things we've been able to determine is that the volcanoes have a very systematic pattern to them where the activity has been migrating over time. So if you go out near Raton, on the western part of the field, the volcanoes are about a million years to a little over 700,000 years. In between Raton and here, volcanoes are younger, between about 370 and 100,000 years. And then when you get to the area around Capulin, the volcanoes are, this one down here is about 60,000 years, and the youngest one's over here about 37. So the volcanic activity over time has been migrating to the east. And that's a really important thing for us volcanologists to know, because what it tells us is that if the past activity continues, we probably should expect the future activity to be somewhere close to where we are now, or maybe a little further east. And what we found is if you look at all the volcanic fields in New Mexico, they all have a very similar pattern. So this is a map I showed earlier. The little arrows represent the direction the volcanic activity is migrating. And in just about every one of these young volcanic fields, we see this very similar pattern of kind of eastward migration. Sometimes it's to the northeast, sometimes it's to the southeast, but it's always moving in that direction. And one potential way to explain that is if you look at the way the North American crust is moving, it's sort of moving opposite. So maybe there's some kind of fixed magma chambers down below, and as the plate moves over it, the volcanic activity is just following it. The last thing I'll share with you in dating hundreds of eruptions across the state is we've been able to get a very good idea of how frequently volcanoes erupt in the state. So a couple things to point out. So across the bottom here, I know these numbers are a little small. This is 500,000 years ago, and on the right is present day. So each one of these little vertical bins represents a 100,000-year time slice. And each one of these dots represents a dated volcanic eruption. And so by looking at different times throughout New Mexico's most recent volcanic history, we've been able to determine the eruption frequency. And there's a fairly strong evidence that over the last 500,000 years, there's actually an uptick in volcanic activity. So for example, if you look back between about 300,000 and 500,000 years ago, there was something like an eruption every 10,000 years to 50,000 years. Between about 300 and 200,000 years ago, there's about one eruption every 7,000 years. Move forward, one eruption every 400,000 years, and the last 100,000 years we see that there's been an eruption about every 3,000 years, which is kind of a interesting number because the last eruption in New Mexico was about 300 or 3,000 years ago. Now I'm not saying we're due for an eruption or anything like that, but what it does tell us is that even though there hasn't been an eruption in New Mexico for about 3,000 or 4,000 years, that's just sort of the common pace at which volcanism happens in the state. So this is some of the evidence that helps us come to the conclusion that volcanism in New Mexico isn't inactive, it's just dormant, and there's a very good possibility we'll see volcanism sometime in the future, probably not in our lifetimes. But so that's sort of what I've been up to, is trying to understand just the pace of volcanism in the state. So thank you very much for your time. This is a picture of baby Capulin, the next youngest eruption compared to Capulin, just further to the north. So if you have any questions or want to chat, be happy to do